These are the notes for Algebra 2, Section 3.8, page 210 to about 211 in your textbook. And what we're going to be looking at are inverse matrices and how to use inverse matrices to solve matrix equations. Now, first thing we need to do is look at some vocabulary. First piece of vocabulary we're looking at is the identity matrix. Now, the identity matrix is a matrix with ones on the main diagonal and zeros everywhere else. So, for instance, if I had a 2 by 2 identity matrix, it would look like this. I would have ones on the main diagonal and zeros in the other spots. If I wanted a 3 by 3 identity matrix, very similar. Again, I would have ones on the main diagonal, and then I would have zeros in all the other places. So we can see we have 1, 0, 0, 0, 1, 0, 0, 0, 1, ones along the diagonal, zeros in all the other places. Now, two matrices are inverse matrices if their product is the identity matrix. Now, I want to take just a moment here to note that it has to work in both directions. That means that the matrix times its inverse equals the identity matrix, and the identity matrix, and the inverse times its matrix is the identity matrix. So, it's just a piece of information that you might see show up somewhere, but I would say it's not directly applicable to what we're doing right this moment. Now we want to look at the inverse of a 2 by 2 matrix because that's what we're going to be using most. We want to be able to find the inverse of a 2 by 2 matrix, and we should be able to do it by hand because it's really not that complicated. Now, we refer to the inverse of A as A to the negative first. That to the negative first power makes it the inverse. To find the inverse, given our matrix, and notice that I'm not using numbers here, I'm using A, B, C, and D, the inverse is always found the same way. I'm going to start by drawing a little X, right, connecting A to D and C to B. Now, this tells us most everything we need to know about using the inverse matrix. Now, there are two parts to the inverse matrix. The first is a fraction, a scalar, that I'm going to multiply the inside terms by. And the other is the matrix itself. Now, what we do to set up the fraction of the inverse matrix is we use what's called the determinant of the matrix. So in this case, the determinant of A. Now, the determinant of A we can get by multiplying the things on the lines here. So I've drawn this X. I have a line connecting A to D and a line connecting C to B. I'll multiply A times D because those two are connected by this line. And I'm going to subtract C times B. C times B are connected by a line as well. So A times D minus C times B gives me my determinant, which is what goes on the bottom of this fraction. It should be fairly simple multiplication. Now you'll notice inside the matrix we have the same numbers, but they've been rearranged. And it's still along this X form. The line from A to D and the line from C to B still hold up. Now what I do is the A to D line swaps places. So A swaps places with D. That would, let's call that the right line, and then the left line is C to B. The C to B, as you can see, changes the signs of the original numbers. They stay in the same place, but now they're opposite signs. Now, there is one little caveat here. It's one that should be pretty obvious to most of us, but I'm going to point it out just in case. A times D minus C times B can't equal 0. Because if A times D minus C times B equaled 0, then we'd have an undefined fraction and the whole thing would fall apart. Now let's give this a shot. We're going to see how this works with actual numbers, not just A, B, C's, and D's. We want to find the inverse of A. I'm going to draw a little X here so I can keep that straight in my mind. Now I'm saying, let's start with the matrix. I'm saying I'm going to switch the places of A and D. So in this case, this line going from left to right switches the places. So I get -4 on top and 3 on the other side. So A and D switched places. Now the other line that connects them changes their signs. So -2 becomes +2, and +4 becomes -4. So that's my matrix part. Now the determinant part, the part in the bottom of the fraction, I get by multiplying the stuff that's connected by the line. So 3 times -4. 3 times -4. And I subtract the stuff by the other line. So 4 times -2. 4 times -2. Now I need to simplify this whole thing, and mostly I just need to simplify this fraction. I get 1 over 3 times -4. Now 3 times -4 is -12, and I'm just going to do that off to the side. -12 minus 4 times -2 is -8. So -12 minus -8. And we know that when we have two minuses together, they make plus. So this turns into -4. So my fraction here is 1 over -4. Okay. Now, sorry. So, we have -4, 1 over -4, I'm sorry. 1 over -4 times all of the stuff in my matrix. And I'm just going to rewrite it here. Now we know from doing our scalar multiplication that in order to actually multiply this stuff out, all we have to do is multiply the fraction times all the numbers inside the matrix. So I have 1 over -4 times -4. Well, -1/4 times -4 is +1. And I get the same thing when I multiply this, -4 times -4, +1. -1/4 times 2 is -1/2. And -1/4 times 3 is -3/4. I could have also written these as decimals, -0.5 and -7.5, but it makes no difference. And this is my inverse matrix. Now I want you to take a minute, go to the checkpoint on the backside of your note guide. We're looking at number 1. I want you to find the inverse of this matrix. Remember to draw your lines to connect the numbers, and then follow the steps. Alright, so we're going to see how we can use this inverse to solve a matrix equation. To solve a matrix equation, what we're going to do is start by finding the inverse. And we're going to find the inverse of A. Before we actually get started here, I want to take a look at what my equation looks like. This is the form of the equation if we ignore the fact that these are matrices. We have matrix A times matrix X, the capital X means matrix X, equals matrix B. So two matrices being multiplied together equals another matrix. Now, normally, if we had AX equals B, we would divide by A, and we would get X equals B over A. There's only one problem with this, and that is that we can't really divide by matrices. We can multiply by matrices, we've done that, but we can't really divide by matrices. Instead, we have to use the inverse matrix to get rid of matrix A. A times the inverse of A will remove it. So we need to start by finding the inverse. Let's go ahead and do 1 over the determinant. Of course, we have our lines connecting the two. My determinant will be negative 3 times 1 is negative 3. Minus 4 times negative 1 is negative 4. Of course, two negatives make a positive. And I'm going to change that because negative 3 plus 4 is 1. And then, look at that, we've got 1 over 1. That's going to be pretty easy. The next thing we need to do is look at the matrix itself. Now, along our line from the right side here, we go negative 3 to 1. Those switch places. So I've got 1 in the top portion, D becomes A, and negative 3 in the bottom. The other line connects 4 and negative 1, and that just changes the signs. So negative 1 becomes positive 1, positive 4 becomes negative 4. Now, of course, since I'm multiplying all this stuff by 1, my inverse matrix is really just 1, 1, negative 4, negative 3. And I'm going to use this matrix to solve this equation. Alright, so to solve the equation for matrix X, we want to multiply both sides of the equation by the inverse matrix on the left. And that matters. As we've seen, the order of multiplication in matrices does make a difference. So, we have to multiply on the left side for both of them. So that's what we're going to do. Now, my matrix was 1, 1, negative 4, negative 3. So that's what I'm going to do, 1, 1, negative 4, negative 3. I'm multiplying matrix A here by its inverse, and I'm multiplying matrix B by the inverse of A. Now when I do that, matrix A times its inverse just becomes the identity matrix, which as we've seen has 1s along the diagonal and 0s everywhere else. The identity matrix is kind of like multiplying by 1. It doesn't actually change the value of matrix X. Now on the other side, we have the inverse of A multiplied by B. So let's go ahead and do that real quick. Now when I multiply these out, of course, you may or may not remember, I start by multiplying the rows by the columns. So I have 1, the first term of the first row. 1 times 9 is 9. 1 times negative 12 is negative 12. So 9 minus 12. Then I have 1, change colors here, 1 times 4, the second column. 1 times 4 is 4. 1 times negative 3 is negative 3. Then I've done my first row and both of my columns. I move on to the second row. I have 4 times 9, negative 4 times 9 is negative 36. Negative 3 times negative 12 is positive 36. Now I have the bottom row and the last column here. Negative 4 times 4 is negative 16. Negative 3 times negative 3 is positive 9. And I want to do all my addition, simplify this down into a single matrix here. We've got 9 minus 12 is negative 3. 4 minus 3 is 1. Negative 36 plus 36 is 0. Negative 16 plus 9 is negative 7. So this is the product of the inverse of A times B. So I have negative 3 whoa, a little big. Let's make that a little bit smaller. Negative 3, 1, 0, and negative 7. Now, since, change that again, I can't get this 3 right. There we go. So, since the identity matrix times x equals this new matrix that we've got here, that means that the x matrix simply equals the product of the inverse of A times B. And we can see these steps out to the side. Matrix X equals the inverse of A times B. And that's going to hold up. You can see, as I said, when I have this matrix like this, normally we would divide, but instead of dividing for matrices, we multiply by the inverse, which is what we've done here. We have the inverse of A times B, and that gave us the equivalent of dividing by A. All right, I want you to solve this matrix equation. If you have a calculator, this should be pretty easy. If not, I would like you to work on multiplying matrices together. Remember that you multiply each individual row by both columns. So you multiply the first row by both columns, then you multiply the second row by both columns. Find the inverse first, and then multiply the inverse of A times B.